We could try and demonstrate it using a deck of cards. And if you think of the red ones representing warm events and the blue ones, the more colder weather events, if we look at weather forecast, we would probably start by mixing these cards up. As a simple demonstration of the rather complex physics that's behind weather forecast models, let's say we pick cards from those as possible realizations, as possible forecasts of how the weather is going to be. Think of a world where anthropogenic climate change wouldn't have happened. We would end up with a distribution of these events that would give us roughly equal chance of getting a warmer or cold event. We could do this lots of times, and this is actually what we do in weather forecasts, and we get quite good quality predictions from those. In the case of increased greenhouse gases towards warmer conditions, we would remove from our deck of cards some of the cold ones, some of the blue cards. We randomly draw again, and we end up with a forecast that perhaps looks a bit more like this. More red cards coming up here. Further increase the greenhouse gases, meaning we're removing more and more of these blue cards in our set. We're getting less and less of these colder realizations, colder possibilities. And if we go to very, very extreme scenarios where the forcing from the greenhouse gases is getting really, really strong, we're removing more of these cards. And what we end up with is an increased chance of more warm events in our predictions. And because of our prediction with the weather systems being tested so well, we're quite confident that these models can represent the physics that's involved in climate change.
Yeah, and I mean, we see quite nicely here as well that the blue cards are getting rarer and rarer, and we're getting more of the hot event cards in our stacks as we introduce more climate change. So yeah.